Alright, welcome Quadrature fans, and today we will do a continuation of the variation on the Johnson Jackson Pythagorean Theorem. And we'll be using, obviously there's trigonometry, there's this staircase ladder network, waffle cone, and then there are also these sum and difference angle formulas. And then, of course, there's the geometric series, and then leveraging of area from various perspectives, the angles, the right angle versus this angle and this angle. And so, in order to do this, we need some preliminary work to be done. I'm not going to prove these angle formulas or this geometric series, but I simply refer you to YouTube channel by Linda Green. That's for the sum and difference angle formulas, and it's nicely laid out. There's a diagram that shows it. She does it pretty good. I like this setup, so that's good. MathyJaphy, he does a pretty interesting setup on this geometric series, 1 plus a squared over b squared plus a4 b4, etc., dot, dot, dot. That has a limiting value of 1 over 1 minus a squared over b squared, provided that a is less than b. And so that's that. All right. And one of the things we have to do is calculate this angle here, and we'll prove that it's really beta minus alpha. And here's how to do it. You start out with 90 degrees is alpha plus beta, because these are complementary angles. Beta and alpha form 90 degrees. And so now you add 90 and you subtract 90, so this equation hasn't changed. And so you have a situation like this. 90 is 2 alpha plus beta minus alpha. That's how you prove that this angle is beta minus alpha. Okay, and the sum and difference angle formulae, and that's that should be a plural form, right? That's, believe it or not, this is an English word, formulae. So we'll be using this a plus b and sine a minus b, because there's a 2a. That's the double angle formula that comes out of this. And a minus b, well, that'll be used for this thing. And so let's set things up. We're still doing some preliminary work. And so what do we have to do? We have to prove u is equal to this 2ac over b, which you factor out. U is this part here, so you got 2ac over b. You factor that out and you get this series, geometric series, which is a limiting process, and MathyJaphy shows that it comes to 1 over 1 minus a squared over b squared. And so the whole thing is u equals 2abc over b squared minus a squared. That's this distance here, right? That's u. And similar, w, well, v is composed of c plus w. And this w is another geometric series where you factor out this 2a squared c over b squared. And you get the same geometric series. And so you work that out algebraically, and it simplifies to 2a squared c over b squared minus a squared. Now you have to get v, that's this distance here, and that You simply C plus this thing and do some algebra and you'll get C in parentheses b squared plus a squared, the whole thing over b squared minus a squared. And so that's that side. The sine of 2 alpha, that 2 sine alpha cosine alpha. Well, that's 2 a over c, b over c, right? Sine alpha is a over c, and cosine alpha is b over c. So this is in the ratio form. So it's 2ab over c squared. And that's 2 sine of 2 alpha, which if you notice, that's the same thing as here. That is the same thing. And then sine of beta minus alpha, that's this angle here. Well, that's simply sine beta cosine alpha minus cosine beta sine alpha, and then in ratio form, that's again b over c minus a over c times a over c, b squared minus a squared over c squared. So that's the preliminary work that we had to do. Here's what we're doing. 1/2 of u times c, that's basically the area of this triangle. This is a right angle. So we can do that, 1/2 base times height, right? Well, that must be the same thing looking at it from this 2 alpha perspective. Of course, when this is not 90 degrees, we have to add sine of the angle that's between these two sides. So area is 1/2 c times v times sine of 2 alpha. Well, plug that all in. This is all just straight algebra. You plug in all these values, and this is what you get. And when you do the cancellations, and I'll let you do that, that's an exercise, you basically come up with this c squared equals b squared plus a squared. It's pretty simple. Most of these terms just simply cancel out. So that's looking at leveraging this area here, a right angle, against this area here. This like times the sine of 2 alpha, and of course 1/2 because it is a triangle. And now here's the second part. Let's look at things from this beta plus alpha angle right here. And so what we have is, again, 1/2 u times c, that's just this right angle, is equal to 1/2 of u times v times the angle beta minus alpha, sine of that, and that gives us area. It's kind of this cross product. And so when you plug all these values in, which we have, this is just straight algebra, do all these plugins, you get, looks pretty messy, but again, what's left is c squared and b squared plus a squared. Everything else will cancel out, and that's a proof. So this is kind of interesting. Believe it or not, formulae is a valid English word. It's taken right out of Latin. Formulae pluralis feminini generis. Formula singularis feminini generis. All right. See you.